For the default constructor, I will just use the debugger on Eclipse to show you how the objects can be visualized. And I'll do the more elaborate drawing when I go to the non-default constructor in the next video. Okay, let's just to be more effective in the illustration. Okay, before I do the debugger, let me just make it a little bit more readable for the console output. Okay, I can say system out the print line. Let's say before creating two members over here. Okay, and then after this, after these two lines, I can say after creating two members. Actually, you know what? I think I can do this. So this will be after creating member one, right? You can see this is right after member one has been created using the new keyword. And let's use another one at the end. So after creating member two, okay, let's have these printouts. And then I'm going to set a breakpoints at different timing. Let me set a breakpoint, actually let's say in the beginning, number 8, and then we're going to see by stepping over to see each line for execution. All right, so as usual, we're going to right click on member app.java, and then I'm going to say debug as Java application, and then I will switch to Java perspective. All right. And then you can see under variables over here, there's nothing like a member one and member two, simply because now we are in line number 8, right before we execute this print line statement, right? So it's no surprise. If I say step over, it would say before creating two members, right? And you don't see member one yet because we haven't executed member one just yet. Okay, we haven't. Okay, for now we don't really need to step into because default constructor is simply just empty. It doesn't, it's not even shown to you, right? It's kind of implicit. But in the next video, we'll show you exactly how to trace the constructor when we define one. But for now, let's see what the consequence is right away. If I say, okay, so now I'm now around line number 9. Okay, if I say, you can see this highlighted in green. If I say step over, we will see member one under the variables over here. That's what we'll see. Okay, if I say step over member one, you can see now we got member one over here. Okay, there's something I want you to see quickly. If I simply click click on member one over here, you can see over here it shows to me model.member. You can see model.member. This tells me where the class is, right? It's under the model package, and the object is instantiated from the member class, right? And then after the add, you can see 6EE52DCD, right? So you can think about its so-called pseudo memory address. It's not exactly the memory address, but the idea is really about the unique address where somewhere in the memory space has been allocated to store this particular member objects. So this is something I will visualize on the iPad for you, maybe in the next video, not for the current one, but just keep in mind. So if you simply click on member one, by default, it's simply just going to show you the unique address for this particular objects. Every time you use the new keyword to create a new object, it's going to give you a different address. So visually speaking, it's just going to allocate different portion of the memory to actually store the objects, right? Okay, member one, and then if you expand the triangle over here, you can see balance, height, ID, name, type, and also weights over here. Okay, so these are so-called structure. You can think about there are two columns over here. The left column here, balance, height, ID, name, type, and weights. So these will constitute the structure of the objects. If you remember in the member class, right? So these are exactly the 1, 2, 3, 4, 5, 6, the 6 attributes we define. So 6 attributes will constitute the structure of the member class, the member objects for now. Okay, and then on the right column here, you can see 0.0, 0.0, 0 null, and also for the type, remember it's character type. It's simply just nothing, right? Just empty. And then 0.0, it's just weights, the default value, right? For now, it's nothing exciting. Okay, it's simply default, meaning that we have created the member objects whose structure is defined by the 6 attributes which we declare over here, right, in the class. Okay, nothing surprising. Okay, so the number one important thing for you to learn from this current video is whenever you're creating a new objects of a particular type, in this case it's a member class, right? exactly how the structure should look like for that particular objects depends on the list of attributes you declare for that class. In this case, since you declare 6 different attributes over here, that's why the structure will be defined in terms of 6 different attributes over here, right? That's the main point you want to remember. All right, let's now go back to the member app over here. So now the breakpoint, so now the current point of execution is line number 10. So if I say step over, I'm going to actually print out after creating member 1, right? You can see member 1 is already here, right? It's the objects with this particular address over here, right? So now what's going to happen if I say step over? Okay, let's predict what's going to happen. Number 1, we're going to see just another variables under the variables panel, member 2, point number 1. Point number 2, if you click on that, it's also going to show you another address. However, is the address going to be the same? The answer is no, it's not going to be the same, simply because we are creating 2 distinct objects. Every time you're using the new keyword separately, you're basically creating a separate object that's being allocated in a different portion in the memory. So the address will also be different. And then when we expand the structure for member 2, are we going to see the same structure? The answer is yes, because it's just another instance from the same class called member. So we're going to see exactly the same 6 attributes over there. But since it's the same default constructor we are using, so we will still see the same default values. Later on in the next video, we're going to see how you can create different objects with different values, even though they got the same structure. Right? You really want to distinguish between structure of the objects versus values for their attributes, right? So these are 2 different concepts. Well, I'm going to visualize that for you. All right, let's now simply say step over. Okay, so now you can see member 1 used to be here. So just remember the address yourself, 6EE52DCD, right? And then if I click on member 2, 449, you can see 4493D195 is apparently different, right? So these 2 objects are simply not the same objects. If they were the same objects, they would have got the same address, would they not? All right, so if you expand the structure for the member 2, you can see, look at member 1 and member 2. Their structure are exactly the same. Balance, height, ID, name, type, weights. Balance, height, ID, name, type, and weights. However, since we're using the same default constructor, you can see member here and also member here. So that's why the initial value 0.0 over here, for example, is the same as the 0.0 over here. They are the same. However, they are subject to changes as we move on. So that's something I will show you how you can change the attribute values using the mutator methods. That's something we'll see later. All right. All right, if I say step over again, okay, so now I'm at the end. So now we have created the 2 members, right? Something more I want to show you on the debugger, right? If you go to expressions over here, let me remove the previous expressions first of all. Okay, something very interesting for you to see. Okay, so now let's talk about equal operator. If I say member 1, you can see member 1. Basically, you can see member 1. If I put it here, that's the address I talk about, right? If I put member 2, that also shows me the address for member 2, right? Which is different. So now, can I actually show that these 2 objects are different objects? So if I say member 1 equals member 2, so that should be true or false. Should be false, because member 1 and member 2, they are different addresses, right? Member 1 is one address in somewhere in the memory, and member 2 is simply just another portion of the memory that's distinct. They do not overlap. On the other hand, if I use member 1 not equal to member 2, that should be true. So I'm saying that member 1 and member 2, they are not the same addresses. They are not the same addresses. They simply denote different portions of the memory. In that case, that would be true. So really think about these 2 expressions over here. We'll revisit this many times later. Okay. All right, let me stop the debugger over here, and let me go back to Java perspective. I would like to put 2 more lines to show you, to summarize. Okay, so sys out print line. Okay, over here. No, I do not want to enable dictation. Don't ask me again. Thank you. All right, so now let's do 2 more lines. Okay, so member 1 and member 2 are the same objects. Okay, if for two objects to be the same, so that means their addresses should be the same. So that means if I say, let's say plus member1 equals member2, right? So I'm basically putting this, but you want to make sure, because this can be a string concatenation, right? You want to make sure you actually evaluate this particular expression first, right? So that's why you want to put this, right? You want to put this Boolean expression over here. I want to know whether this is true or false. If this is true, so that means they are the same objects. If this is false, that means they are not the same objects, right? So that'll be one expression to print out. Let me just maximize the panel over here, right? And number two, I want to show you, member1 and member2 are distinct objects. Distinct objects. And if they're distinct, simply means their addresses are simply different, right? So whenever we talk about member1 over here, and also member2, they really refer to the addresses for the objects. That's something I will try to visualize even more explicitly and precisely in the next video. But for now, it's good to always know the facts first. All right, if I try to run it, okay, it will say member1 and member2 are the same objects, simply false, because member1 and equals member2 is going to give you false. On the other hand, let me go back to the console here. If I say member1 and member2 are distinct objects, it's going to be true, simply because member1 not equal to member2 is going to give you true. Before I end the video, I would like to show you how you can put these two expressions into JUnits as two assertions. Let's see how we can do it. It's actually rather easy. I can also introduce to you some, two new assertion methods that you can write in the JUnit tests if you want to try it out yourself. All right, let's go back to Package Explorer, and then I'm going to create a new JUnit test class, right? Right click, and then I'm going to say new JUnit test case over here. Let's call that, let's make sure we choose JUnit 4 and also test member, right? So it used to be test utilities, but now since we're testing a different class, so that's why I said test member. Okay, and then I'm going to say finish, and then make sure we add JUnit 4 into library path as usual. All right, so now let's say test member 1. Okay, that's a test number 1. Okay. And then here, let's see how we can do it, right? I can just be a little bit lazy here. Let's go back to member. Let's go to the test member, the member app. Let's go back here, and I can simply just copy these two lines. That's what I need. I'm gonna get rid of the system out of print line later. Okay, so let me go back to test member here, and then simply paste. Okay, I'm gonna get rid of this middle line over here. As soon as I copy and paste, I'm actually going, you can see it will automatically import model.member as before, right? Remember, if you want to use the class, you must import it. In case you don't have this statement here, you will have compilation error, so you got to add it, add this line yourself. All right, so now here, remember the principle is, in the JUnit test class, we don't put any system out of print line. That's why I deleted that. Okay, we got member 1 and member 2. So there are two things we can do. We want to make sure they are different addresses, right? So I can say, for example, assert. Okay, usually we say assert equals. You know what? You can actually say something like this. You can say assert equals over here, and then if I want to say member 1 equals member 2. If I want to do this, that should be equal to actually false, right? So this should be false. And then let me create another test over here. You can see this corresponds to exactly the two printouts to the console I just explained to you. Let's say test member 2, and then these two. So if I say member not equal to member 2, what do I expect to see? I expect to see true. All right, like this. Okay, let's try to run this test case. If I say right click and then run this, oh, sorry, not member, test member. Right click and then say run as JUnit test. Right, I will see a green bar over here. That's pretty good. However, let me show you another one, an alternative, which you can definitely try to use if you wish. I will put this into comments. Okay, and then what I can do now is I can say something called assert false. Okay, control space, assert false. is just another assertion I can write in JUnit. So whatever Boolean condition over here, I'm expecting that to be false. So here I can say member1 equals member2. Okay, and symmetrically you can kind of predict what's gonna happen for the second one. Let me put this into comments. There's another one. Let's say assert control space. I would say assert true over here. So whatever I put inside as a Boolean condition is going to be true. So I can say member1 not equal to member2, right? So this will work equally. Okay. So now if I rerun the JUnit test, I will see a green bar over here, right? So you can see these two assertions over here correspond to exactly, if I go back to member app, what I will see over here. This will be false and this will be true. But again, you can see the great advantage about writing JUnit tests is once you define them, every time I want to check, I can simply just click on run and then I'll see a green bar or a red bar, in which case I gotta fix something. On the other hand, if you always stick to the member app console application, you always rely on your eyes to actually check manually whether you're going to get an expected result. So again, it's really important to keep emphasizing the great advantage of using a unit testing framework like a JUnit. All right, so that's about what I want to say for this video here. And in the next video, I will speak about how you can use a non-default constructor that you can customize yourself, and then I'll visualize it using an iPad.